In this section, we're going to graph combinations of functions, and our first one involves a algebraic function along with a trigonometric function. Let's graph y equals 1 plus sine x. Now, we've done this kind of graph before, but we're going to look at it a little differently this time. I'm going to look at this as y equals y1 plus y2, where y1 is equal to 1 and y2 is equal to sine x. So if I graph y equals 1, that's just going to be a straight line that looks like this. It's about as straight as I can draw it right there. And if I graph y2 equals sine x, that's just going to be a sine curve. Now let's see, it's going to have a period of 2 pi, so it's going to look like this. There's one complete cycle. There's two complete cycles. So now what I want to do is add these two graphs together to get the graph of 1 plus sine x. So one thing I can say is that anywhere one of my graphs is 0, I'm on the other graph. So when I add these two values of y, 0 plus 1, I'll get 1. When I add these two values of y, 0 plus 1, I'll get 1. These two values of y, I'll get 1. These two values of y, I'll get 1. And these two values of y, I'll get 1. Where both graphs are 1, my red graph and my black graph are both 1 right here. When I add those together, I'll get 2. Here's another place where they're both 1, so I'll add those together. That will be 2. At this value of x on the x-axis, one graph is 1, the other graph is negative 1. 1 plus negative 1 add to 0. I have another point like that right here, where I have 1 plus negative 1. That gives me 0. So if I connect these points with a smooth curve, I have the graph of the sum of those two functions. So my blue graph right here is the graph of y equal 1 plus sine x. A couple of different ways to think about this. You can think about it being the graph of y equals sine x moved up 1 everywhere, or you can think of it as the sum of y equal 1 and y equals sine x, and we just go add our y coordinates. Let's take a look at a little more difficult one. I have y equal 3 sine x and y equal cosine 2x, and I want to add those two together. So let's let y1 be equal to 3 sine x, and let's let y2 be equal to cosine 2x. So first, let's graph y1 equal 3 sine x. That's going to be a sine curve with an amplitude of 3. So it will start at 0. It will go up to 3, back down to 0, down to negative 3, and back up to 0. So I'll get a curve that looks like this. And here it's going to go back up to 3, down to 0, down to negative 3, and back up to 0. And like this. So there's the graph of y equal 3 sine x. Next, I want to graph y2 equal cosine 2x, which is a cosine curve with an amplitude of 1 and a period of 2 pi divided by 2, or just pi. So this goes through one complete cycle in pi units on the x-axis. So I'm going to start at 1. It's going to end up at negative 1 halfway, and then back up at 1. So that curve is going to look something like this. Okay, let's see if I can sketch that. Here's halfway. It'll look like that. Here's halfway, so like that. And then here's halfway, so. Okay, so there's my graph of y2 equal cosine 2x. Now what I want to do is add these two graphs together to get the graph of y equal 3 sine x plus cosine 2x. Let's try it. Like I said before, anywhere one of the graphs is 0, I'm on the other graph. So here I'm looking at my red graph. It's 0. I must be on my other graph. So I'll put a little dot there. Here my red graph is 0, so I'm on my other graph. Here my red graph is 0. I'm on my other graph. Here the red graph is 0, so I'm up here. And here the red graph is 0, so I'm up here. Let's look at where the black graph is 0. Here the black graph is 0, so 0 plus this value of y must be that value of y. Here it's 0, so I'm at that value of y. Here the black graph is 0, so I'm down to this value of y, 0. I add those two together and I get that. This 0 plus this y is this y. This 0 plus this y is this y. Down here, same thing. and down here the same thing. Now let's see, at this value of x, my one graph is 3, my other graph is negative 1, so when I add 3 and negative 1, I end up with 2. Down here, this graph is negative 1, this graph is negative 3, so together they add to negative 4. Over here I have 3 plus negative 1 is going to give me 2. And over here I have negative 1 plus negative 3 is going to give me negative 4. So you can see that I have sort of an outline of what this graph should look like, the sum of these two graphs. So I'm just going to connect these graphs with a nice smooth curve, and I'll get the graph of the sum of those two functions. So, whoops, I should have been up there, right? Yeah. Okay, so it looks something like this. Now, this is really good enough for graphing by hand. If you graph this on a graphing calculator or you do it on graph paper and do it a little more accurately, you'll see that the graph actually, this little part here is a little bit wrong. It should come down and then go back up like that. This is okay. But up here, it should go up, come back down, and then like that. But for the amount of accuracy I have drawing it here on the chalkboard, this is good enough. We just want to practice putting these two graphs together as best we can, adding our y-coordinates up, and looking and see if we see a pattern between the points that we've drawn out and then connect them with a nice smooth curve. So you might want to try this problem again on a graphing calculator, or maybe you want to try it on some graph paper drawing a little more neatly than I did here, and you might see this little part right here that I couldn't get with the accuracy that I'm doing on the board right here. But still, you get the idea behind graphing these combination of functions.